Okay, perfect. Welcome to the second community call in April. Glad you could join us today. I'm just going to share my desktop here a moment. So our agenda today is that we're going to cover some of the things that are going to come out in the 0.7 release. I'll talk about the release after we've kind of gone through a few of these updates. We're going to have Shalabh do a little bit of a section on what we're doing to update on some of our distributed tracing work to help improve what you see inside the application map and also in terms of how we do the tracing itself. We're going to have Youngbu do some updates on service invocation, particularly how we do cross HTTP and gRPC calls. Yaron is going to look forward into our next release in terms of how we're changing some of our bindings proposal to make it bi-directional. I'll give you an update on the release itself, and then of course we're always open to Q&A at the end, and we're going to always try and leave it a good 20 minutes there for open Q&A. But we like these to be interactive, so after each one of these sections we'll always stop and ask for a chance to ask some questions. As always, all these recordings are placed on Dapr Recordings, which is our YouTube channel. So with that, I'm going to unshare, stop sharing here, and I'm going to hand it over to Shalabh, who's going to kick it off and talk about the updates to our distributed tracing work. Shalabh.
Yeah. Let me share my screen. Hello everyone. So everyone can see my screen?
Yes, we can see your screen.
Yeah, hi. I'd like to update on the distributed tracing key enhancements that we are doing in 0.7 release. So some of the key enhancement earlier before 0.7, there was improvements like the improvement that we have done in terms of doing the W3C context header. Like earlier, we are not using the standard headers. In 0.7, we are following the standard headers like HTTP. We are doing trace state and trace parent header. And for gRPC, we are doing trace bin header. And so this way, with this approach, we are able to track operation ID and correlation ID across the headers, and that can be tracked across microservices. The second enhancement we did over in terms of easy tracing configuration. Earlier, now the sampling rate is now configurable, and we have the configuration now looks like very simple. We have the tracing config, and all we need to provide a sampling rate. So sampling rate, sampling can be turned off when we provide sampling rate 0 and 1 is the maximum, and that way it creates a sampling rate and it's easy to turn on and turn off the tracing. And the third major improvement that we provide in terms of providing the correct application map on Azure Monitor. Earlier, if we see the map, it looks something like that. We were tracing a lot of Dapr internal calls and a lot of all the spans we are tracing it. But now the improvement that we made is like, this is the operation that I did it using the sample calculator app, the distributed app, which I did as you know, each operation is itself a microservices. And when I do operations and I see the application map, so the application map looks like this. Here we are calculator front end is kind of a client microservice, and all the operation has its server microservices. And we are generating client span and server tracing span separately. And you can see that from this calculator front end, I have done 3 division operations, 2 subtract operations, all that. So it looks cleaner in terms of like, so customer user is only aware of his own application context and not get into the details of Dapr internal calls. And if they want to troubleshoot that further, we have a single operation ID that can be used to correlate the traces. As I said earlier, it is traced by the standard headers. And another thing is like, if you want to see the details of the operations, now you can see that we can see the slowest request by name, and this name shows like what's the operation that we perform. So it kind of helps investigate performance across the microservices. We can see and we can run query, and we can see each query is correlated by the correlation ID. So we can run push the query on Azure Monitor. So in brief, what the improvement is like in terms of application maps, it looks cleaner. And also in earlier, the same improvements, because of the same standard header improvements and the client and server span generation, we have Zipkin tracing as well. We can use Zipkin and we can say each operation is actually independently by a trace ID, and we only see client and the server span. And if we click on Zipkin, so by the way, this is a Zipkin monitor, and we can see how the calculator front end operation sends a divide operation and how much time it takes, and it can show you all the methods succeeded or not. Earlier, it was something like earlier in 0.6, it was something like this. The same trace, we see there are a lot of internal calls. It gets a little confusing to diagnose, but now we have pretty cleaner and pretty cleaner traces. So this is in terms of the improvement that we did. It gives the clear application map and the tracing spans. And another thing that we like to update on this, we have using another thing that I like to highlight here is this is the article that I like to tell about, which talks about the things happening in the open telemetry space. So Mark, you can send it over share this link. Today we have open sensors SDK and agent by which we are emitting the traces and using the local forwarder to send the traces to Azure Monitor. And we can have other exporters like Zipkin and Jagger. But in this release, we have tried out Open Telemetry Collector, and we see that it works as well. In terms of, we try the Zipkin and Azure Monitor. So Azure Monitor, we have some issues, but there are some issues, but still it's working in terms of like other operational data. So today in 0.7, we are having open sensors can be used with Open Telemetry Collector as well. Going forward, we would have Open Telemetry SDK as well. But for now, it's open sensors, which can be used as local forwarder or any other exporter, along with Open Telemetry Collector. So this is the overall major updates in terms of distributed tracing. What we made make it a standard header oriented, same correlation ID that's passed in the header, easy configuration, and we are generating a correct application map and the Zipkin trace and the traces spans. And yes, so that's all for the update from the distributed tracing side.
That's good, Shalabh. Thank you. Actually, it's worth pointing out and just bring up your configuration. Let's just talk about that a little bit. If you just got the thing there before on the configuration, you'd see that we had sort of 3 settings that you'd have to turn on. It was turn on tracing itself, turn on whether you want to replicate headers and the body of the message, and it was a little bit unclear about what those would actually give you. If you just put up the example inside your notepad you just had there, you see now that it's just a single setting. And it just is sample rate.
So in the deployment, we need to create a configuration like a trace configuration, and in the configuration of the Dapr app configuration, and we provide the tracing section. In that tracing section, all we need to do just sampling rate, which will turn on and turn off the tracing. Earlier that we are providing some bunch of parameters, which is not needed now anymore. Just single configurable sampling rate, that is enough. And, and we can have a separate and like we have, see the deployment I'm picking up, and we can have a default exporters. Right now this is open sensors exporter, and we have to provide the agent endpoint in the cluster that I'm showing. I've used the local forwarder. So I deployed the local forwarder, Azure Monitor local forwarder, and I give the agent name to the exporter configuration. So that's it. Basically, one is like collector, exporter, and enable tracing into the application.
Shalabh, can you show the configuration again?
Yes, the sampling rate one.
Sampling rate one, yeah.
Yes.
Yeah.
Yeah, so it's important to note that those configurations can be applied on a per application basis. So they're not global, which is kind of cool because you can decide different sampling rates for different applications. So one application can have, a 1.0 sampling rate, and the other will have, will only trace 50% of the calls, for example. So these are set per configuration, per application, and they're applied using the Kubernetes annotations that you deploy on your YAML. You can find that in our docs. And if you're running Dapr locally or in a different environment, there is basically a configuration parameter that Dapr takes in where you can point in to the configuration file.
Yeah, and I think by default we'll have the sampling rate turned on. So sampling telemetry is turned on by default with a low sampling rate. I think the value is 1 in 10 samples. Is that right?
Yes, it's like 0.001.
0.001, yes, which means you're gonna effectively if you put 0, you get 0, no sampling. In other words, you get no telemetry. If you put 1, you log everything but have a performance hit. And then and this is basically the recommendation that you see in telemetry or diagnostic tracing systems anyway, that you sample at the rate that you think the events occur that you want to see.
Yes, yeah.
That's great.
The tracing configuration is being deprecated. Is that correct? I want to make sure that I understood that.
Yes, it's changing. Effectively, the current configuration of the tracing where you turn on enable tracing and there's a couple of headers, that's going away, and it'll be replaced only by sampling rate.
Okay.
So sampling rate effectively is if you have a sampling rate of 0, you have no tracing. If you have a sample of 1, you trace absolutely everything in the system and have the corresponding perf hit. The default is on by it's 0.01, which means that we trace basically the minimum rate. And this is basically the recommendation you get in, if you go and look in the OpenTelemetry spec, they talk about a sampling rate there in terms of capturing every 10th event or whatever you want to do in order to be able to see diagnostics inside the system or your trace inside the system.
Okay, and I know that tracing today is configured globally. Yaron said this is per app, which is awesome. Is there still a way to configure it globally or no?
It's configured like it is today. I mean, today you configure an exporter globally, and then you have the configuration file, which you can apply to all the applications by the annotations, but those annotations are still per application.
Okay.
So that's not really changing. Yeah, I just want to make it clear for the people who don't know.
And just to be clear on, I posted the article about the Open Census, Open Telemetry because just to make sure that a viewpoint here. So right now, the format that we're using is Open Census as the trace format. But we're going to be moving when the standard becomes fully accepted to Open Telemetry. But so the exporters you have right now are exporters that take on the Open Census format and push that out means both the Zipkin and into the Application Insights application map. But in the diagram that Shalabh showed inside that Newstack article, you can hook up an Open Telemetry collector which understands the Open Census format to push that into any diagnostic tracing provider that you want to push it into. So say something like Datadog provides an Open Telemetry collector that by default understands the Open Census formats, and so you can make it all work. So feel free to try that out that way.
Yeah, that's all the update from my side, from the distributed tracing side. So
Okay. Great. Are there any questions that people have? Feel free to either open up your mic or just post them in the window. The whole idea is hopefully make, one of the key aspects of Dapr is to provide very clear performance tracing and give you the clear views both through diagnostics application maps like this one inside App Insights and then in the Zipkin one as well. So we're keen that you can try this out and give us feedback. Good. All right. Well, if there are questions that pop up, that's fine. Let's jump on and move on to our update from Youngbu on service invocation.
Hey, hello everyone. This is Youngbu. I'm going to share my screen. Can you see my screen?
Yes.
Okay. So I'm going to talk about the service invocation improvement in this milestone. So we have been hard work to improve the service invocation in this milestone. So service invocation is a kind of like a core one of our core building block in Dapr. And Dapr provided the gRPC and HTTP API to call the HTTP or the gRPC applications over the internal gRPC. But the previous implementation, implementation of the service invocation works really well for the the first case. If the user use HTTP API and a user try to call the HTTP callee applications, but the other case, for three cases, if the user use HTTP API and callee app use gRPC server, or vice versa, or caller app uses a gRPC API and callee app uses gRPC server, then it doesn't really work well as compared to the first cases. So we try to figure out what is the gap between the HTTP request and response and gRPC request and response, and try to fill out the gaps in this milestone and provide a consistent service invocation behavior to the customers. So so if you want to know that in detail about the problem and then how we improve that, you can go to this link to see those detailed specs. But I would like to highlight a couple of these improvements in this presentation. So in this new like 0.7 Dapr can transfer like header and metadata between two different protocols from HTTP to gRPC or gRPC to HTTP by minimizing the loss. Basically, for example, if the user try to pass the binary metadata through the gRPC request, we are not transfer the binary data to the HTTP data. There's some limitation, but we try to minimize this type of limitation now. And if you want to improve more, then you can always like create the issue to improve that limitation. But right now we have some limitation. You can take a look at the detail in the spec. But yeah. And the second thing is that we new implemented translated responsive status code between the HTTP and gRPC. So what happened is that so when the user uses a gRPC API to call the HTTP applications, and then HTTP application returns the non-successful status code to the gRPC caller applications. But in previous implementation, even if it's the HTTP application returns like non-successful the response code, it always the gRPC app always gets the successful response code. But in the new implementation, we translate the response code between the HTTP and the gRPC status code. And we translated the response code between the HTTP and gRPC response. So when in the new like implementation, when you call the gRPC API to call the HTTP application, and the application returns like non-successful HTTP request, then gRPC application can get the exception. Well, we're gonna show some demos in the later after this slide in detail. So and then we And we introduced two protobuf methods to fill the gap HTTP protocol. So one is the HTTP extension protobuf message, which includes the HTTP method and query string. So with this, basically, if you're using gRPC service invocation API to call the HTTP application, you can now you can pass the HTTP method and query string explicitly. In the previous code, we basically assumed that the method is post and there's no way to pass the query string to the HTTP applications. But with this protobuf messages, you can pass the HTTP method and query string to the HTTP request with the gRPC API. So, and then the next protobuf message, data with the content type protobuf message, which allows to set the content type and body when you call the HTTP application with the gRPC API. So in the previous implementation, we are always assuming that the content type is application JSON. There's no way to specify a content type for the request body. With this, basically, even if you're using gRPC API, you can specify the HTTP content type. So we're going to show these examples in the demo. And also, you can use this protobuf messages for your gRPC to gRPC communication as well. And the last thing is that I would like to highlight, basically, right now, service invocation building blocks support the API version. Later, once we introduce a new version of API, let's say we introduce new V2 version of API service invocation, then right now there's a way to in the new implementation there's a way to handle this different API versions. Any question? So if you want to know in detail about the change, you can check this link, and you can see what is the problem and how we resolved it. What is the problem? What is the gap between HTTP and gRPC in terms of Dapr point of view, and how we resolve that issues. So if you don't have any questions, I would like to.
Why don't you jump in and show a little demo, and then
Okay.
maybe that might encourage people to go and spark some ideas and questions.
Yep. So okay, yeah. So this is a kind of the breaking changes. So we changed the gRPC method and then some the gRPC protobuf messages. So if you're directly using protobuf client, then you may need to change your user app code. But if you're using the .NET SDK or Java SDK, you can just upgrade the SDK version. You don't need to change your application code.
Or if you're using HTTP directly, right?
Yes, yes, you can use HTTP. There is no changes in HTTP API. So I'm going to show some demo. Basically, this is a Python application which you use the protobuf client. This code basically, this is this application calls the gRPC service invocation API, and this one is a callee application, which is HTTP server application, which exposes two endpoint. First one is the concat, which basically this endpoint can get the two string and then concatenate it to string and returns that result to the caller applications. And the second the endpoint basically is to show how we translate the HTTP status code to the gRPC status code. So I'm going to show how we are passing. The first demo is to show how we pass the content type and specify content type and pass the body data, and also how to pass the HTTP verb. So if you take a look at this code, basically we first need to specify, first need to construct data with content type message. We need to specify the content type for the HTTP application. I set the content type is the application JSON, and the body is this serialize the this object, which is including two string. One is like Dapr, and the sidecar we are expecting that get the response which includes like Dapr sidecar string. So this is the data we will be sent to the concat application, and if you take a look at in this the above message, so basically this is the request message for gRPC service invocation API. So this is a target application ID, which is concat, and then we need to specify exact message, for example, which API we will call, and this is concat, and then we will need to pass the message that we defined before. And also the last thing is that we need to specify the HTTP extension. We need to specify exact verb. If you don't specify exact verb, or if you miss this property, Dapr sidecar will return the error. So we need to make sure that we always need to specify the HTTP extension. So let's try to run this application. So I already run the HTTP concat application here, and then let's try to run caller application here. So let's see. So you can see this. You can call. What is that? Sorry, it is hiding.
I think we can see it. What is it you're looking for?
Okay, I mean it's like the Zoom's control panel is hide my screen, so I can see the result.
Oh,
the
results there.
Yeah, I moved that. So I moved the panel so I can see it now. So you can see that we passed the toString, and then the concat returns concatenated string. It shows the result like this, right? This is basically shows how to specify the exact the HTTP verb using the gRPC API, and also how to specify the exact content type for the HTTP application. In the previous implementation, we always assuming that this content type is application JSON. So, but we can specify exact content type.
This is also a nice example of showing how you can invoke an HTTP RESTful API using gRPC.
Yeah.
With Dapr acting basically as a bridge.
Right. That's true.
Yes.
And then second example, I will remove this. And then I would like to show how the HTTP status code is translated to gRPC status code. So here's things. If you are using like gRPC API to call the HTTP application right now, the Dapr sidecar behavior will be different. What this means is that right now we are translating the HTTP status code to gRPC status code. So if the gRPC API returns non-successful response code, basically you will translate it to the gRPC status code, and then we will throw the exception. I'm going to show how it works. So basically, so as I said, we have concate service has another endpoint which is called action, and it will allow the delete. It will allow the only delete method, and then it will returns 4 not found non-successful response code. and then we'll see how it will be translated to the gRPC status code. So in the previous code, as I said, it will always return like successful, but from 0.7 Dapr release, we will see the actual status code as a gRPC response code. So let's see how it goes. I removed the comment here. Okay, so I will rerun the code. So you see this, so you can see this, basically it will throw the exception because Dapr sidecar is translated to actual the gRPC status code. Then you can see the status code is not found, which is the gRPC status code, and it will throw the exception, RPC exceptions. Yeah, that's any question on this?
No, I think that's all good. I think the important thing here is that we've sort of done all this hard work now to correctly translate between gRPC protocol and HTTP protocol both ways. So
yeah.
As Yaron pointed out, it acts as a bridge between the two now, whereas before, they were very different protocol formats. And so now you can get, the correct error messages, the correct calling semantics, and the correct types of verbs.
Yeah. Okay, that's all I have.
Right. Well, people got any questions on this? I mean, hopefully the idea of this now is that you can take advantage of Dapr to help you make sure that when you're calling across gRPC and HTTP protocols, all the right behavior happens. And before there was some set of assumptions we sort of put in place, it sort of worked. Now we've been a little more precise about how it works and provided a specification for it and what it looks like and written that into that issue that Youngblue talks about. So it's kind of an interesting, in some ways, it's like a spec to translate between two different protocols, which I'm not too sure if that's necessarily been published before, but it'll be interesting to see how it aligns with anyone else who may have done this approach. But that's what we're going off for, making sure that we're clear on. Good. Any more questions? And then we'll move on. Great, so let's move on then. Yaron, would you like to share your screen?
Yeah, no problem. Let me share. All right, let me know when you can see the browser.
Yes.
Okay, so we're going to talk about bidirectional bindings, which is a pretty nice feature that we're going to add into Dapr 0.8 or 0.9. No promises there. And it all started in February when a lovely chap named Yaron Schneider opened this issue on our Dapr repository, basically proposing to get responses back from bindings. And this picked up a little bit of traction. We heard from people in the community and from customers also that this would be beneficial. And then discussions ensued, as you can see here. And after a lot of discussions and a core container meeting that we had last week, we basically arrived at an updated design decision, which you can take a look here. It's issue 1016. And basically what it means is that up until now, you were able to trigger your application with events that are coming in through Dapr input bindings, and you could send out messages to output bindings, for example, to write a blob to S3 or Google Cloud Storage or Azure Storage. And you would only get a response back saying if the operation succeeded or not, meaning if it succeeded or failed. And you wouldn't be able to do things like, get me a blob or list all the blobs in the storage account. And like I said, we got a lot of messages and responses from multiple people saying that they'd like to see that. And so we came up with the following changes to the Dapr API. So these are going to be breaking changes, although they're going to be pretty small, because all it basically boils down to, as we're going to see now, are just 2 additional fields on the request. So for example, we're adding a version and an operation fields to the output binding, and this is what it's going to look like. For example, this is a theoretical call to list all blobs in an Azure storage container. So the API call would be pretty much the same call as you know today. You're calling Dapr over localhost. You're invoking the bindings API and a my storage binding. So at that point, you have the Dapr component YAML, which has all the connection info settings in it for my storage. And then you have the request object itself. And those new fields are things that we didn't have before. And we're really moving into very schematized, well-structured payloads that we will be releasing for every components contrib version and Dapr version. So it's very clear to our users exactly which inputs binding expect and which operations they support. And also for any given operation, what's the expected payload. So there's not going to be any magic or guessing there, which sometimes occurs today with output bindings for Dapr. So for example, in this request, we're specifying a version, which is the version of the binding. This is the version of the API for Dapr. So the API might change. For example, we might add resources on top of the API endpoint URL, but the request itself might have a different schema. So we have pretty good versioning support all the way through. And then we're basically saying, hey, invoke this storage binding with the operation of list, and there's no additional metadata here. And what will happen is that that specific binding will return a structured payload, for example, an array of all the calls, of all the blobs in the storage account. Similarly, this is how you would create a new binding. This is similar to how you do it today, really. So this is how you create a blob today. You specify a metadata with a blob name, and this is a per component specification. We have that today in our documentation under API references and bindings. And we will be adding a lot of specific info there once binding components are extended to support other operations. And the operation here is create, and this is the data that we're sending, just a wee message. So this is really quite similar to what it is today, just with the addition of the version and the operation here. This is an example of how we'd get a blob, that very same blob which we just created. So we're again calling the bindings API, and really the request is the same, only we change the operation to a get operation. And so every component in the components contrib will be able to tell the Dapr runtime which operations it supports. So for example, if you're trying to call the Azure Blob Storage component for a specific version with a delete operation, and that specific component didn't support that, you'll get a really explicit error saying, hey, the Azure component for bindings with a version of v1 does not support the delete operation. And that basically allows us to perform validations for the operations themselves, return very explicit error messages, and then also be able to have components define exactly which operations they support. So we don't have a common denominator between them, unless we want to. And about the response payload. So for example, if we take a look at the API call here, we're listing the blobs, just like we've seen earlier. And for example, this is the response. So we're calling list on the my storage account. And this is basically the response we're getting back, a theoretical response because that capability doesn't exist today. But this is, for example, what it might return. And all the requests and responses will be schematized and published as part of the components contrib releases. And also they will be documented in greater detail inside our documentation repository. So that's all from my side. If you have any questions, ask away.
Well, what's pretty cool about this is that I think that we've had a number of people ask us, can you provide a building block for file I/O and all sorts of other different types of systems? And this sort of effectively approaches that with a way more generically, where a binding is both an input or an output thing. That's the general concept of a binding. And now can either just trigger your code as it did before, or with the output bindings, you actually get hold of the actual return type for whatever the resource was.
Yeah, it'll allow for much more, for many more use cases than we can see today.
So a quick question from me, it's Johnny. Is the sort of list of operations going to be fairly well defined, or is this something that if you add a new binding, you can start sort of adding whatever you want in there as long as it's documented? 'Cause it feels like you could end up with a very inconsistent API and various things implementing different things in slightly different ways. So you're going to have to make sure that we're pretty tight on consistency.
Yeah, so our thoughts were really the latter from what you said. So any type of component can define its own operations, and these need to be clearly defined. If we see, for example, that it causes, I don't know, some sort of inconsistencies, then we might want to limit it, but the control is all ours, really.
Okay, fair enough.
This is Haishi. Maybe we can consider in the future to require the component to return the list of options when we query them.
Yeah, that's actually what's going to happen in the implementation, so that we know exactly which operations are supported.
To parlay into that, can you have the component as well? Like, so for a given operation, get in your example, I know that metadata, so the parameters for that operation, if I understand correctly, will be carried in the metadata section. Is that correct?
Yes.
Yeah, so a couple of things. One, it sounded like you're going to return detailed error messages if, for example, I put my operation as foo and, my component only supports bar operations. I should get an error message, detailed error message back. It says, Lynn's component does not support foo, for example.
Yeah.
Will I get similar error messages back if I specify like parameter names that don't exist? Like if I, fat-fingered blob name, for example, or if the get operation required the blob name be set, but you didn't pass in blob name. Have you put any thought into how you're going to handle those types of error propagations back to the caller?
Yeah, so required properties will return an error, right? If you put some extra metadata there that's just not used by the binding, you won't get anything back.
Okay. And I think that the other thing to kind of complement what Joni was saying is, it's definitely, I think it's a great idea. I love it. It's really cool to be able to get responses back. But I'm kind of with Joni as well in that, when you go down the bindings route, as opposed to, some of the other more well-defined things like pub/sub and state store, you're going to lose the ability most likely to, swap out bindings, right? So if I had a Cosmos DB binding and a SQL Server binding, depending on how people implemented their operation names and how they implemented the parameters in the metadata section, I wouldn't easily be able to change between the two like I could, for example, with the state store. And I think that we just need to be really clear in the documentation, because that is some of the magic of Dapr, right? Of, early on, we've seen that people are just like, wow, this is really cool. Hey, I'm using, Redis for pub/sub, and then I switch over to Service Bus instead, and I didn't make any code changes. That definitely won't be the case, most likely with bindings. Right?
Yeah, but then again, it probably wasn't really the case to begin with bindings.
Agreed.
Bindings, sorry?
I said I agree with you there.
Yeah.
I mean, yeah,
So
they're definitely a different animal.
Yeah,
Yeah,
exactly. So for pub/sub and state, you get that compatibility, but bindings really are like external systems, very different kind of building blocks. So, I mean, you could get that portability today, but bindings are, unlike all the other building blocks, they're less expected to be able to support that level of compatibility.
yeah, makes sense.
Cool.
Good.
All right.
Any other questions? We'll have an open question time in a moment. Let me just share my screen here a moment. I will just give you a little update on where we are with the milestone. So we're talking about a milestone update. We're in the middle of shipping our 0.7 milestone. As always, we build everything in the open. Here's a project you can go and look at. Specifically because of a lot of the changes you've seen today, the service invocation work and with the observability work, we realized that we have to make sure that we do a bit more testing, write a lot more test cases, get the end-to-end test cases in place. And so that's resulted in the fact that we're actually going to be moving the milestone out by a few days So we were trying to ship the milestone this week. It's not going to happen this week now. And we're actually pushing out the actual release date until the Tuesday of next week, so the 5th of May, to give us some time for extra testing to make sure that we're really solid about this thing. We'd rather have the release be a little bit later than a few days and make sure that we've done the required testing on all this to cover those things. But of course, meanwhile, that doesn't prevent you, if you want to go and take the master branch, build it yourself and try everything out, feel free just to take hold of that. So that's just a little update there. Another thing I also wanted to point out that we did tweet about is that if you do want to do a Dapr presentation, we keep a deck up to date here, which is underneath the docs repo, underneath presentations. So you can go and find the latest doc in here. In fact, I'm just about to refresh it with a PR that I've pushed out today with some additional changes to it. So feel free to take this deck, and if there's some things that you want to see in it, push some changes into this as well. It's designed to have a deck that you can sort of keep a few slides, throw some things away, depending on who your audience is. And then finally, if you wanted to go and watch another session on Dapr that I did a couple of days ago, the Global Azure did a session, and I just did a live session here, which was another sort of a refresher and update on Dapr and what it was doing. So feel free to go and check that out. And as always, all of these videos that you have today get posted on our Dapr YouTube channel here, and I'll post this one out afterwards. So with that, I'm just going to switch it back and have a chance to open it up for the last 10 minutes for any questions that people have. Feel free to ask us any question of your choice. It really doesn't matter what it's about, release timelines, particular features, asks, particular issues. We really don't mind. I mean, it's an open Q&A time for whatever you want to talk about.
So I'll go first if no one else is going to jump in there. Do we have any idea? I know there's a closed issue, and I talked with Archer about it a little last night. Do we have any idea when or if we're going to support service-to-service invocation between namespaces? I'll give you my example here. So if I've got, for example, I don't know, an ingress controller that's running in, my cool ingress namespace, and I want to Dapprize that and have it actually make calls to my Dapperized components that happen to be running in, Lynn's cool application namespace. That doesn't seem to be possible today. Is there thoughts on making that possible in the future, or am I going to have to lump everything that my application needs into a single namespace from a service-to-service invocation perspective?
So there is actually a way to do this today. You can basically in your ingress route define a service with the Kubernetes DNS, full DNS resolution that has the namespace inside of it, and then just point that instead to the local Dapperized instance, so to a Dapperized instance in the other namespace. That's kind of a hacky workaround, although it's valid. I think, and this is really a question to Mark, Fussell also, and to all of the Dapr maintainers on the call. Yes. We talked about this feature in terms of the universal namespace, which is a feature that's supposed to be able to take one application in one cluster, in a given cloud, and be able to connect it and have it invoke other services in a totally different cluster, maybe even running on an edge environment, as if they were in the same cluster. And this feature would basically also work for this use case, but maybe we should start off by having cross namespaces within Kubernetes and then grow towards the universal namespace.
I agree. I think that, it'd be interesting to come across more use cases. Your one's an interesting one in that, you have the ingress controller inside, inside one kind of lockdown domain. Yeah, it's a bit like a security domain, and yet you want to keep your applications in another different namespace around these two. So it seems a very much valid scenario that you'd want to achieve.
This is a Haishi. I have a local proposal. I will upload that to the GitHub repository so that people can see how that should look like. How about that?
Yeah, man, very cool. Can you send me the link when you do that, Haishi?
Yeah,
yeah, definitely, yeah.
Can you put it in a chat window at the moment?
No, it's local on my computer. I need to put
okay.
into the GitHub.
Yeah. Okay. So let's create an issue. I think it's a good one. It's certainly one valid big where people want to put their applications in different namespaces for security and deployment purposes, and then we can dive into that. And it is something that I can see as being an interesting scenario when you start to Daprize, particularly your scenario with ingress control and what that looks like.
Cool.
Yep, definitely.
Good question.
By the way, you can also just set up a cross namespace service. You know, if there's one in particular you need to go across, I do that a lot.
By setting up a routing rule?
Oh, and you can have a service basically just be another basically DNS entry that aliases one in another namespace. I forgot what the service type is called.
Okay.
Yeah, that's possible also. But regardless, we'll want to support it natively with Dapr so that people won't have to make explicit hosting platform configurations to achieve that.
Good. Okay, that's a great question. I noticed in the chat window that George posted a question to everyone about making a generic binding for DocumentDB or GraphDB, and let their underlying provider figure out the implementation. That's one thing you could do. Yes.
I think that's a great idea. Actually, I was thinking about that. To have some portability across bindings. Say people that say if you want to create like a generic T-SQL based binding, then you can bind the database to like SQL Server or MySQL or different databases. I think there could be some use cases there.
Yes.
Although you can do that today with a state store API.
Yes.
Right, but state store give you the key value, right? If you want to have like a more specific relational high style access to the databases, you could use such kind of binding.
Yeah, so that's possible today. For example, with the way bindings work. I think, you know, regardless, we were talking about providing relational capabilities to the Dapr state to basically extend the Dapr state API for OData. There is a really good issue that was raised, really detailed by Johnny. And so if you go to the Dapr repository and you check for the issue, just search for OData, you'll be able to get it. It's very detailed and it's a pretty good proposal. So for everyone here, if you'd like to see relational capabilities, relational database capabilities inside of Dapr, that issue is a really good place to start, and we'd love to hear you.
Yeah, I'm not sure if we want to overload the state store though. I like the simplicity of key value access, unless someone has a different opinion.
Yeah, I mean, it's not changing the key value API. It remains the same. We'll just be adding another additional API model, similar to how Cosmos DB works.
But does that increase the burden of implementing a state store? Like
No. Today, for example, we have different interfaces that state stores can implement. So, you know, some of them are transactional and some aren't. So it'll just be another capability that's implemented by another interface on the state store.
I see, like a separate OData interface?
Correct, yeah.
Okay.
Okay, with that, I think we are done for today. Thank you for joining. The next meeting that we have will be on the 12th of May. So in 2 weeks' time. There's also 2 in May, so there's also be one on the 26th of May. On that time, we'll give you, we'll have released a 0.7 release, and we'll give you a little update about that if there are any additional things that we didn't cover in one today, and we'll also look towards what's sort of the things that we're going to be doing in 0.8 release. So see you in 2 weeks' time, and thank you for joining.
Thanks, everyone. Bye.
Yeah, thanks, everyone. Bye.
Thank you.
Bye-bye.
See you guys.